Okay guys, I'm looking at page 188 in our workbook. I'm also going to look at page 189 in a second, but I just want you to, this is kind of everything that you need to know about coordinate geometry proofs. And again, we've done a lot of proofs before, but all of them were just kind of in, like, you know, in space on a piece of paper. We didn't anchor them to anything or put them in a position. But when we talk about coordinate geometry proofs, we're plotting points to get a shape, and we're going to prove that it's a certain shape using coordinate geometry. And so those three things that we're going to need, the formulas from the videos that you've been watching, are distance. That's going to tell us how long a side is. Midpoint formula, again, that's going to come in when we're asking, do these two diagonals bisect or things like that. So finding the midpoint of them. And then finally the slope formula. And I have a little note here for you. Two lines are parallel if their slopes are equal, and two lines are perpendicular if their slopes are negative reciprocals, right? Negative reciprocals. And what you need to know about that is if I give you a slope, let's say that something has a slope of negative 2/3, then if something has a slope of positive 3/2, all right? So first of all, let's ignore that negative part. Reciprocal just means the flip. Take a fraction and flip it upside down. So I would take the 2 and put it in the denominator and 3 and put it in the numerator, right? And then I would get 3/2. The negative reciprocal means basically it's the opposite of whatever this one is. So if you want to think of negative as being the opposite. So is it flipped and the opposite sign of the original one that we were given? All right, so here if our slope was originally negative 2/3 and then I'm looking at something else that has a slope of positive 3/2, this is the opposite or the negative of negative 2/3, and it's also the reciprocal of negative 2/3. So when we're talking about opposite reciprocals, it takes two things. It takes a flip and a change of sign. All right, so don't say that negative 3/2 is the negative reciprocal of that, because they're the same sign. It means the negative of or the opposite of this. So they won't both be negative. One will be positive, one will be negative. All right, so this one is not the opposite reciprocal or the negative reciprocal. Okay, so you might want to write that down because people tend to forget that, and it does come up here. Okay, so I just want to talk you through this. I am going to let you use this on the test, but I will send you a copy of it so that any notes that you write on this are yours strictly for when you're doing your work, not for on the test. All right, so in order to prove that something is a parallelogram, you have to do one of these four things. Don't do all of them, please. That's way too much. All right, so one way to show that something is a parallelogram is prove or show that both pairs of opposite sides are parallel. How will you do that? You're going to use the slope formula. So again, if they're parallel, their slopes have to be equal. So you would find out what their slopes are, show that they're equal, and then they would be parallel. All right, that's one method. A second method is to show that both pairs of opposite sides are congruent. All right, so are they the same length? If they are, or in order to show that, you're going to have to use the distance formula to find the length of each side. All right, a third method is to show that one pair of opposite sides are both parallel and congruent. I can't remember which of the formulas that was, maybe the frog formula, I'm not sure, but anyway, show that they're parallel and congruent, but this time it's just about one pair of sides. There you would have to use the slope formula for the parallel part and the distance formula for the congruent part. And then finally show that the diagonals bisect each other. This is where the midpoint formula would come in. You would have two diagonals and you would find the midpoint of this one and then the midpoint of this one and show that that midpoint is the same. In other words, that they bisect each other. All right, so that's for proving a parallelogram. Again, you pick one of those. This is the formula or formulas that you're going to need to use. All right, for a rectangle, there's only one way, well, I guess one way to do this, but all right, let's see. Find the slope of all four sides. First show it's a parallelogram because the opposite sides are parallel, and then prove it's a rectangle by showing it's a parallelogram with right angles. All right, so we're going to have to find the slope, so we need the slope formula right here. So find the slope of all four sides. That's where we get the slope. Then we're going to have to show it's a parallelogram because opposite sides are parallel. That comes from the slope. And then prove it's a rectangle by showing that it's a parallelogram with right angles. And again, the right angles come in because that means that the sides have to be perpendicular. That also comes from the slope formula. All right. So it looks long-winded right here, but all the information we need is going to come from the slope formula. All right. For a rhombus, all you have to do is show that all four sides are congruent. All right, that is by definition what a rhombus is, and so we would just use the distance formula there. All right, for a square, you must show both of these things. Show that all four sides are congruent. That is going to show that it is a parallelogram and a rhombus, and then show that the diagonals are congruent. All right. So for all four sides are congruent, that would be the distance formula for the sides, and then show the diagonals are congruent, that would be distance formula again, but it would be with the diagonals, not with the sides. All right, trapezoid, show that one pair of sides are parallel and show that the other sides are not parallel, right? If you show one pair of sides are parallel, and then just stop. If the other sides are parallel also, it's actually not a trapezoid, it would be a parallelogram. So in order to do this, you must show that one pair is parallel and that the other is not parallel, so that it's not a parallelogram, and you have to find the slope of all four sides. So you're going to find and show that these two are parallel and then these two are not. If it's an isosceles trapezoid, you must show both here. Prove that it's a trapezoid, which is what we did in the previous one, and then show that non-parallel sides, these two sides along here, are congruent. That's what it means to be isosceles. Prove it's a trapezoid. Again, that was the slope. And then to show that the non-parallel sides are congruent, that is going to come with the distance formula. This should be hyphenated. And a right trapezoid, that's a trapezoid that looks like this, where there's a right angle. Prove it's a trapezoid, so show that one pair of sides are parallel and the other are not parallel, and then show that one set of sides are perpendicular, so this side and this side are perpendicular. So prove it's a trapezoid, that required the slope formula. Prove that one set of sides are perpendicular, again, that slope formula. You must make sure that you're picking consecutive sides right here. You'll have the diagram to help you pick which pair you want to look at. And you're showing that the two consecutive sides are negative reciprocals. In other words, that's what we talked about up here, that two lines are perpendicular if their slopes are negative or opposite reciprocals. There are a couple other proofs that we're going to come across in here. I think one is show that something is an isosceles triangle. Again, that would be isosceles triangle, show that two sides are congruent and the third is not, so two sides congruent and third is not. All right, and that would be distance. And then the other one I think comes up would be a right triangle. And there you would just have to show that one pair of sides are perpendicular. That would be the slope formula. And then the last one I think was equilateral. Something's an equilateral triangle. All three sides are congruent. And that would be distance again. Right. Hopefully when you get to them, you would figure that out, because it's much easier to show that things are isosceles or right or equilateral, or even scalene. If it were scalene, you would show that none of the sides were congruent. But again, triangles are very easy to do because there's not really a whole lot of types, but there's a lot of, if you remember from that whole chapter we did on the quadrilaterals, there are a lot of different forms there. Okay, and then I just want to talk about this, page 189, because you're going to be like, oh, I don't want to do proofs, these are different. I'm giving you these tips for making sure that you do a good proof here. All right, so organize your work and label everything. This is my biggest pet peeve, is that you just do calculations everywhere and then I have to figure it out and I get angry and then I take points off. So please be neat about this. If you find the distance of something, say what it is that you're finding the distance of. So don't just do the computations. Make sure you tell me that this is the distance of between A and B, or the length of A and B. All right, so don't leave it to me to guess. All right. Second, label your algebra statements clearly. For example, if you're going to prove that a figure is a parallelogram, by definition, one thing you need to do is find the slopes of its side. When you do that, write something like the slope of BC is, and then do it. So again, this kind of follows in here. Label it. Tell me what it is that you're trying to find. Third, you have to refer to your calculations and provide a summary of proofs. Don't just do all of them and think that's enough. And this should kind of come in like a paragraph form, not a paragraph, but just sentence form. And I have an example here when you're done. So interpret it for me, basically, is what I'm saying. So for example, if you've just finished finding 4 slopes in a route, now ready to say that a shape is a parallelogram, then you would finish by saying something like this. BC and AD are parallel because they both have slopes of -1/4. So up here somewhere you would have just found that. Here you're making a conclusion. You're saying, see, they both have the same slope, therefore they're parallel. AB and CD are parallel to each other because they both have slopes 4/1. All right? So again, your work would have been somewhere else. You're just writing a summary here. Since both pairs of opposite sides are parallel, by definition, it is a parallelogram. All right, and so you're making a conclusion. You're not just leaving your work here raw. You're pulling it together into a nice statement right here to explain your thought process. Do not turn any fractions into decimals like that. Reduce all your fractions. And that you must show algebraic work for things in your proof. So don't just make a claim, they look parallel, or I did rise over run and I found they're parallel. Show your work. All right, and if you do rise over run, that's fine, but just you're going to say slope of BC, or whatever it is rise over run, and you're going to put -1/4, and you'll show me that. So even if you don't do algebraic work, even if you do rise over run, you still have to show it. Okay. I don't mean to freak you out with all this stuff. It's going to make a lot more sense once we start doing the proofs, which we will do in the next video. So you're going to need pages 190, 191, and 192. All right, bye.